Welcome to the basics of Python programming, part 8. This is the last part of this sequence of videos on basics of Python programming. So in this video, I will demonstrate a Python library known as Pandas. So this Pandas has many advantages over this NumPy library. So NumPy library was already discussed, right? This Pandas was built on top of NumPy library. So using this Pandas, first let me show you how to create some Pandas data structures. Basically this Pandas supports two data structures. So first one is called series, the second one is called data frame. So the data structures are series and data frame. And then there is other data structure also, panel. Let me demonstrate this series and data frame for you. So series is basically a one-dimensional data structure. It was similar to your one-dimensional NumPy array, but it has some additional advantages. So those additional advantages we will see. Let me create a NumPy array first, then let me create a series. So let me create a NumPy array. Let me pass a list 1, 3, 5, 7, 9. Let us say these are the elements. So first let me import NumPy because I am demonstrating NumPy. NP. So we have created a NumPy array. You see the result, how it looks like. We know how it looks like. It was running. Okay. In the meantime, let me import this Pandas library. So like other libraries, you can import this Pandas library as import Pandas as, let us say, PD. This is the standard name. Now you see this is the NumPy array that we have created just now. 1, 3, 5, 7, 9. Now let me create a series. So there is a function called series. So you can pass a NumPy array, you can pass a list to this series. Now we'll see what it will create. First of all, let me pass the same list. 1, 2, 3, 4, no, 1, 3, 5, 7, 9. 1, 3, 5, 7, 9. You see, can you see the difference between this NumPy array that we have created and the series, Pandas series data structure that we have created just now? So if you see what is the additional thing that was added here, this first column, there are two columns here. Although we have given only one column, two columns are coming here. What are these two columns? This first column, what is the second column? Second column is data that we have given, that is clear. What is this first column? This first column is indexes. So here, if you store this NumPy array in some array A, let us say, now let us say this is the array A. You can access these elements using indexing, right? A of 0 will give you the first element. This is the first element, A of 0. Index starts with 0. So here in the Pandas, it will return explicit index. So these are the indices 0, 1, 2, 3, 4. So by default, in NumPy array also these indices were there, right? You can access, let us say, third element, A of 2. A of 2 is the third element. You can access. Then what is the advantage of this series? After all, it was simply printing indexes. So does that mean it is advantageous over NumPy array? No. So in this Pandas, you can give custom indexes and custom column names. Column names we will see later. Custom indexes. You can give custom indexing. Custom indexing means what? So if you see, there is an attribute index. So by default, no need to pass anything. If you want, you can give custom indexes. Let me give a custom indices. Then my indices are like this. Let us say 2, 3, 4, 5, 6. Only 5 elements? Yeah, 5 elements. Now you see, so now let us store it somewhere. Let us say S, series is S. Now let me show you what is there in this series. This is the series object. Now these are the indexes. Now if you want to access something, S of 2, you give S of 2, what it will print, you see? It will print 1. So these are explicit indices. Now it no longer starts with 0. It starts with 2, 3, 4, 5, 6. So using these explicit indexes, you can add. So is it continuous? Not necessarily continuous. You can give any indexes. So let us say, let me give, instead of 2, 3, 4, 5, 6, 7, let me give 2, 4, 6, 8, 10. Does it work? Yes, it will work. You can see what is there. and you can access also using this indexing. Now the next question is, only integers are allowed as part of indexing, as part of this custom indexes? No, you can give strings also. Suppose let me give strings A, B, C, D, E. So it supports characters also. You can give character or string, you can give sequence of character also as index. Now you can access them using S of A. S of A will give you 1. So this is about the series object. Sorry, series object. So similarly, this we have this data frame object, which is a two-dimensional data structure. You can create this data frame using pd dot data frame. This is the function name. You can pass two-dimensional list. Let us say, let me call two-dimensional list. Let me pass 1, 2, 3, 4. Okay, otherwise let me give some values. 10, 20, 30, 40, 50. These are the values, 50, let us say. And then second one, let me give something. Bala, Rao, Prakash, NITW. Now let us see what it will create. If you see here, it was creating 5 columns with 2 rows, because these are the 2 rows, right? Now if you want to create, so if you see the structure, it is a tabular structure it was returning. So if you want the other way, let us say if you want 2 columns and 5 rows, then how you should give? You should give comma 5. You want 5 rows, so you should give 5 lists here. Inside list you should give 5 lists. You want 2 columns, let me give 10 Bala, 20 Rao, 30 Prakash, 40 NITW, 50 Warangal. Now let me run it. You see here, you have 2 columns and then 5 rows. Now the advantage of this data frame or series object is that you can give custom row indexing we have seen. You can give custom column indexing also. For that, you have to use a attribute called columns. For columns, you can pass list of things. Let us say the first one is, let us say age, and the second one is, let us say name. You can specify like this. Now you see what it will create. Can you see? This is the column name, this is the column name, second column name, first column name. Right? You can store it somewhere. Let me store it somewhere. DF data frame. Now you can see what is there in this data frame. Now if you want to access individual columns, you can access individual columns by indexing with column name. Let me give age. See, it was returning first column. Similarly, you can access the second column using df of name. So this is indexing with column names also. So this is the idea of data frames. So basically it will create a tabular kind of structure. So the other advantage of this pandas includes, using pandas you can load big data sets. The data set may be numerical, right? The data set may be an Excel sheet or CSV file, anything. So let me show you how to load a data set. So it is simple. If you want to load a CSV file, use the command read underscore CSV, this one. Okay, then you have to pass the file name here. But since I am working in Google Colab, I need the file to be here. Okay, so what I do is I use 2 commands to load the file from local drive to Google Colab. So these are the commands. From Google Colab, import files. This is the command, import files. Files dot upload equals to So I am storing this loaded file in uploaded. Let me run this one. Now you see what it will ask. It was asking for you to choose a file. Let me choose a CSV file. Let me choose this dirty data CSV file. This is a CSV file. Yeah. Now after loading this file, if you click here, this file will come here. You see, it was loaded. Now the file, a CSV file was loaded from your local drive to or Google Colab. Now you can read this dirty data .csv by simply passing this one. Now you see, it has read this one, this dirty data.csv. This is the content inside this file. This is the column 1, this is column 2, this is column 3, this is column 4, and so on. You see. Now, if you see this data, there are some nans. Nan means not a number, not a number. That means the values were missing inside this data set. So Pandas has a support for what? For dealing with these missing values. So first of all, here we have seen row by row and we have found that some null values were there. Now how to find whether a data set has really null values or not? So for that, first let me store it somewhere. Let me store it df. Right? Now we know what is there in df. Let me show you once again. This is the data. Now if you want to see whether null values are there or not, you can run a command df.info. You see how many rows were there? 32 rows were there because index starts from 0 and 31 means 32 rows were there. Now if you see this one, duration, column duration, 32 non-null values, whereas date 31 non-null values. That means there is a null value. Similarly here 30 non-null values. That means there are 2 null values in calories. So okay, so now we are clear that there are some null values are there in missing values are there in our data set. Now if you want to drop those missing values, you can simply drop using df.drop na. What it will do? It will drop missing values. You see what it was dropping. Earlier how many columns are there? 5 columns. 1, 2, 3, 4, 5. Now if you see drop null values. What it was dropping? It was dropping rows wherein null values are there. If you see here 19, 20, 21, 22 was missing. You see, because earlier if you see the original data set, 22 contains a null value, right? Not a number, so it was dropped. Similarly 18 was dropped because not a null value was there, right? Let me show you this 18 and 22, at least 18, 22 and 28 also a null value was there. So if you see here 18 was dropped, 17, 19, 18 was dropped, then 21, 23, 22 was dropped. Then similarly 27, 29, that means 28 was dropped. So this way you can drop the rows containing null values also, right? So suppose you may say that I don't want to drop rows, I want to drop columns wherein null values are there. That you can do. Now someone else says that why are you dropping all the rows, entire row, just because there is a missing value? I don't want to drop the entire row, I want to fill that missing value with some value, let us say. So for that this Pandas supports a function called fill null value. Now you have to pass the value. Let me fill null value with 100. Now you see, earlier what are the values? 18. Yeah, 18 was filled with 100, 22 was filled with 100, date was filled with 100. Similarly 28 was filled with 100. Now if you see here, date was filled with 100, but this is not an appropriate way of filling. So what we have to do is, we have to check each column and fill a respective value, fill a proper value. So what we do is, we access each column. Let us say date. Let me choose date and let me choose the missing values in date column with current date. So let me give current date as, let us say 2021, 16 and 8. Let me fill with this one. So I have to give as a string, I have to pass. Now let me fill. Now if you see, here it was filled, you see 2020, yeah, not this one, I think this one, 2021, 16, 8 was filled, you see. So similarly you can work with other columns. Suppose some other column where is there the calories. This calories contains calories. Let me run it first, whether it is there or not. No, it is not calories. Yeah, this is calories. Now some null value was there. If you want to fill this one, you call simply fill null value, fill NA, you give some value. Okay, you can give some 50. Now on the other hand, you may say that I don't want to fill with some random value. I want to fill this with some mean value, mean of the column. So what do we do? First let me calculate mean. First I will calculate mean of the column, right? This is 304. Let me store it somewhere. Let us say this is average. Now what we do? Simply df calories. What I do? Fill null value. So missing value is with what? I will fill with the average value of the column. So this is how we fill. You see 304 somewhere was filled. You see 304. Yeah, this is on 304. This is other 304. Right? So this is the way to fill missing values with some random value and filling the missing values with some statistical value, average, standard deviation. You can do whatever you want. You can fill with whatever you want. Okay. Similarly, you can check whether your data set has duplicate rows or not. So for that there is a command called df dot duplicated or not. You can check this df dot duplicated. It will return true or false. False means this is not a duplicate row. True means yes, it is a duplicate row. Now if there is a duplicate row, then we simply wanted to ignore that row, right? We want to delete that row. So what we do? Df dot drop duplicates. You simply run this command, then you see those duplicate row. What is that row? 12 was dropped. You see 12 was dropped, 11 and directly 13, right? So this is some brief description about this Pandas library. So this data pre-processing operations such as identifying missing values, filling the missing values with random values, filling the missing values with some statistical approximations. Similarly, identifying duplicated rows, removing duplicate rows from the data set. All these data mangling operations can be done using this Pandas operation. Further, using Pandas, you can give custom row names, means custom row indexing, custom column indexing also. So that's all about Pandas. So we have reached this 4 hours of this basics of Python programming. So let me conclude this basics of Python programming, all the sessions. So we started with essentials of Python. We started with identifiers, rules. What are the rules to use an identifier? Then we have discussed what is a variable, how to declare a variable, means how to use a variable, and the advantage of variables in Python, right? No need of defining the data type. Then we have seen the operations that can be performed on these variables. Then we have discussed some collection data types, lists, tuples, sets, dictionaries, strings. Then we have covered control statements, if else, if and else. And then we have covered break statement, continue statement, and looping statements, for loop, while loop. That was also covered. Then we started libraries, discussing about libraries. A library for dealing with numerical values, NumPy we discussed, right? And then we discussed about a library for symbolic mathematics, SymPy. Then I have given a brief description about this SciPy library also. Inside SciPy library, we have seen this linear algebra module. Then finally, we have discussed this Pandas library. Using Pandas library, you can load some data, you can identify missing values, you can handle those missing values, and then you can identify duplicates, you can drop duplicates, and many other things can be done. But due to limited time, I am covering only these some libraries and basics of Python. Okay. I once again thank the organizers for giving me this opportunity. Thank you all.